So now that you've all become experts at foiling, which is multiplying binomials, we're going to look at a couple of special products. And the first one we're going to look at is squaring binomials. So we're going to begin with the example of a plus b times a plus b. And you can see both of these binomials are exactly the same. So we can actually rewrite this as a plus b all of it squared. Let's say we use the same method that we learned last lesson, which was foiling. So this is good review as well. We're going to begin by multiplying the first two numbers or terms together, a times a, which is going to give us a squared. Then we're going to go to our outer numbers or letters, which is a times b, which will be ab. Then FOI, we're going to go to our inner two letters or numbers, which is b times a, and you can write that as ba or ab, it doesn't matter. And finally, our last two terms is positive b times positive b, which is going to give us b squared. We collect like terms, and we end up getting a squared plus 2ab plus b squared as our answer. Okay, so this is all good. We've learned this before, but I want to show you that there are actually patterns that come from a question like this. So let's look at this example again, and I'm going to write it over here. Let's say we have a plus b squared. And this pattern, of course, it's optional. If you want to use the pattern to be more efficient and a little bit faster, you can go ahead and do it. But if you are confused and don't like it, then you can always just FOIL like you were doing before, like I just did over here. Okay, so here's how you're going to do it. You're going to take the very first term in this and you're going to multiply that to itself. So a times a is a squared. Then you're going to take the last term and you're going to multiply that to itself. So b times b is b squared. Now we get to the slightly more confusing, not really confusing, challenging part, which is figuring out the middle term. To figure out the middle term, you are going to take the first term, you are going to take the second term in the binomial, multiply them together, and then multiply that by 2. So a times b is ab, multiplied by 2 is 2ab, and the sign is going to be positive because positive a times positive b is positive ab times 2, positive 2ab. And I forgot to write the sign over here. Positive b times positive b is positive b squared. So you're going to notice that this is our traditional FOIL method, and this is the method where we look at the pattern, and we end up getting exactly the same answer. One just takes more steps, the other one is a little bit faster. All right, so let's look at another example of squaring binomials, and this time I'm going to look at a minus b times a minus b. So we're just doing the same thing, except I want to show you what it looks like when they're minus signs. You can rewrite this, or you may see this rewritten as a minus b all of it squared. And we're going to do this using the patterns just so we can practice it. So you look at the first term and you multiply that to itself. So a times a is a squared. You look at the second term and multiply that to itself. So negative b times negative b is positive b squared. Okay, now we need to figure out the middle term. So what we do for that is we take this a times negative b, which is negative ab, and multiply all of that by 2. So we end up getting negative 2ab. And you can prove this to yourself by taking this and FOILing it. So I'm going to do that really quickly here. We're going to have a squared minus ab plus b squared. And when I gather like terms, I'm going to get a squared minus 2ab plus b squared. And we end up getting exactly the same answer, whether we use FOIL or we use the pattern. All right, just for practice, let's try these two examples, and I'm going to use both the methods just so I can show you what they look like. All right, in the first example, we're going to go ahead and FOIL this. So we have 3x minus y. When I'm FOILing, I like to write it out like this, just so I know that there are clearly two binomials and I'm using first, outer, inner, last. Okay, so let's begin with first 3x times 3x, which is 9x squared. The outer terms are 3x times negative y, which is negative 3xy. Inner is negative y times 3x, which is negative 3xy. And I write very large, so I'm definitely going to run out of room. I'll erase that line. Okay, and then negative y times negative y is positive y squared. Finish this off, 9x squared minus 6xy plus y squared. Okay, and what I've done here is I have used FOIL. Let's try using our brand new pattern to do the exact same question. You take the first term, multiply that to itself. So 3x times 3x is 9x squared. Now you're going to take the second term, which is negative y, and multiply that to itself. Negative y times negative y is positive y squared. Now we are going to figure out the middle term over here. So to do that, you take this 3x times negative y and multiply it by 2. If you like, you can write that out somewhere. So it's basically 2 times 3x times negative y. And that's going to end up giving me negative 6xy. And again, compare the two, and you're going to notice they end up being exactly the same. This one, the one on the left required more steps. The one on the right did not, and we just used what we had learned before. The second type of special product that we are going to talk about today is multiplying conjugates. And conjugates is a word that you haven't heard before. So I'm going to give you a couple of examples, and hopefully by the third one, you kind of know what's happening. So x minus 5 and x plus 5 are examples of conjugates. A plus b and a minus b. 2x plus 5 and 2x minus 5. Do you see the pattern? The pattern is both conjugates end up having exactly the same terms. The only thing that differs is one has a plus sign, one has a minus sign. Doesn't matter what order you write them in, you just notice that one has a plus sign, one has a minus sign. So how can we use that to figure out a pattern? So we have a plus b times a minus b. Let's start by just foiling these and looking at it the old-fashioned way. So a times a is a squared. Then we have negative ab plus ab minus b squared. And you're going to notice what happens is when I clean this up, the middle term actually disappears. So you end up getting just a squared minus b squared. So if you wanted to know a pattern, when you have two conjugates, which are terms that are exactly the same, just one has a plus sign, one has a minus sign, all you're going to do is you're going to take the first two terms, multiply those together. A times a is a squared. Take the second two terms, multiply those together. Positive b times negative b is negative b squared. And that is your final answer. And these questions actually tend to be quite easy to do if you recognize that they're conjugates. Okay, so here we have two examples. Let's try them. We're going to do the first one using FOIL, and then the second one I am going to use our pattern. All right, so FOIL. And you know, if you feel that I'm going a little bit fast with the FOIL, it's because I'm assuming you've learned it from the last lesson. And if you are confused, just pause and try it yourself. So this is going to be 4x squared minus 10x plus 10x minus 25. These two terms will disappear. Whoops. So we're going to end up getting 4x squared minus 25. Okay, now let's say we recognize that these were both conjugates, and now we want to use the pattern. We take the first two terms, multiply those together. 2x times 2x is 4x squared. We take the last two terms and multiply those together. Positive 5 times negative 5 is negative 25. And you will notice that both of these answers are exactly the same. All right, so let's say we have an example now with everything all together. So in this example, I have a squaring binomial with a constant in the front, and I also have two conjugates that are multiplied together. And what I'm asking you to do is basically solve this entire expression. Okay, so let's begin. I'm gonna use the pattern because I want to save time. I told you guys last time that whenever you have a constant in the front, just save it, ignore it for now. We're gonna deal with that later. Okay, so because this is squaring binomials, we think about our pattern from before. We take the first term and we multiply it to itself. 3x times 3x is 9x squared. We take the last term, 4, and multiply that to itself. 4 times 4 is 16, and we write that all the way at the end over here. To get the middle term, I'm going to multiply this times 2. So 3x times 4 is 12x. 12x times 2 is 24x. And there's a plus sign, so it's going to be plus 24x. And I'm sorry, I should have written plus 16 because positive 4 times positive 4 is positive 16. Minus sign, and now let's figure out what these two will be using our pattern. We have conjugates, so I'm going to take the first two terms, multiply those together to get 16x squared. I'm going to take the last two terms, multiply those together to get negative 25, because I know when we have two conjugates, there is no middle term. And now we are going to distribute this 2 to every single term in this bracket. And we're going to, well, let's do that first. So we're going to get 18x squared plus 48x plus 32. And now there's a 1 over here, which I'm going to distribute into this bracket. So I'm going to have negative 16x squared plus 25. And I've told you guys many times our goal in this entire unit is, well, not in the entire unit, but whenever we're dealing with questions like this, is to get rid of the brackets so we can move things around. So now we're going to gather up those like terms and we are going to try to solve this. All right, so we have 18x squared minus 16x squared plus 48x, and there's nothing else for that, plus 32 plus 25. What color have I not used? Okay, let's go back to this one right here. 18x squared minus 16x squared is 2x squared. Can't do anything with the 48x. Keep that as is. And then the last two terms, 32 plus 25 is going to give us a 57. And that's the end of that question.